Hey everybody, this is just a real quick warning. This is going to be a little bit longer of a video. So this is going to be organisms and their sensitivities to changes in pH. Real quick, pH again is how acidic or basic something is. What the heck does that even mean in the first place? All right, we got to talk about the dissociation of water molecules. So with that said, there's a way that we look at acids and bases, and that can be seen in this picture below. I'm going to bump this up. If you look at water, it's H2O. If you look at water, it's H2O. I got two water molecules. When they're around each other, believe it or not, they dissociate. What does that mean? It means that sometimes a hydrogen may pop off. Maybe an oxygen and a hydrogen pop off. And they bind to another water molecule. What? That's crazy. What does that look like? Well, H2O and H2O. Let's take one hydrogen from this one, this water, and attach it to this one. See what that looks like. For a brief period of time, you can have OH, one oxygen, one hydrogen. It's missing a hydrogen. And you can have H3O. It's got three hydrogens and one oxygen, so it's added a hydrogen. Okay? What just happened? It just changed the acidity of each of these atoms. Sorry, these molecules. They're molecules, not atoms. How? Well, it's all about the hydrogen. The more hydrogens you have, the higher the hydrogen concentration you have, the more acidic it becomes. The less you have, the more basic it becomes. Hence, the terms you're going to see here, hydroxide, which is when you're missing a hydrogen, hydronium, when you have an extra hydrogen. This is reversible. In other words, it can go back to two waters. It happens all the time. So the water you drink, this actually happens. You don't even notice it because it just goes back and forth all the time. At equilibrium, basically all the water's normal. It is not ionized. What does that mean? These are ions. How do I know it's an ion? Look, it has a minus sign. If it has a minus sign, it's an ion. It's charged. Oh, look, a plus sign. If it has a plus sign, it's charged. Okay? So what I'm trying to say is this. If you add hydrogens to something, it becomes more acidic. If you add more hydroxides to something, OH, it becomes more basic. Right? Another way you could do this, if you remove hydroxides from something, it'll become more acidic because it'll have more hydrogens because you got rid of the hydroxides. If you remove the hydrogens, that means you have more hydroxides. It becomes more basic. Those are the four ways you can do it. Bottom line is this. If you have more hydrogens than you have hydroxides, you're typically acidic. Right? If you have more hydroxides, you have hydrogens, you're going to be basic. Okay? Things to keep in mind. All right. Got some questions. Pretty nice. A couple things here. All right. pH scale. Something important to know. Okay? The pH scale, when the pH scale is based at a 14. It's 1 to 14. You guys have probably seen that before. Here it is. pH scale is 1 to 14. If you are in the middle of the pH scale, well, that means that you are neutral. That's 7. All right, how do I know that? What's in the middle of 0 and 14? 7. Okay. As you move towards the 14 side, you actually become more basic. All right, you have less hydrogens, more hydroxides. As you move towards the left-hand side, towards 0, you become more acidic. You have more hydrogens and less hydroxides. All right. Well, blood, sorry, I keep switching slides. Blood's at 7. Around 7, 7.4. So what happens if my blood goes to like, I don't know, like 9? Is that bad? Let me answer that by telling you this. What does the scale even mean? Right? The scale is based on the number of hydrogens, the pH scale, and increases or decreases by a factor of 10, which is pretty significant. So, for example, if you go from a 7 to an 8 or from a 7 to a 6, you are changing the concentration by a factor of 10. Let's use real life here. Let's say you just got hired for a job. Let's say Dunkin' Donuts. I don't know. I just got Dunkin' Donuts today, right? And they're going to pay you the middle of the scale, a 7 on the scale. Okay. You are making $10 an hour. Okay. It's money, right? If you get a promotion and you go to an 8 on the scale, right? So if you're going from a 7 to an 8, that means your salary just went up 10 times. Your salary just went from $10 an hour to $100 an hour. That's what I'm talking about when it comes to the pH scale. You don't just jump from 7 to 8. Don't get me wrong, I would like that if I worked at Dunkin' Donuts and they're like, hey, we're going to go from 10 to 100 an hour. What? Right? You're going in the middle. All right? So it's a huge difference. Another way to look at it is you're making $10 an hour. Listen, we had budget cuts. We're going to just drop you to number 6 in the scale. Shouldn't be too big of a deal. So now I just went from $10 an hour to $1 an hour. That's the point. All right? So that's the idea with the pH scale. It's a tenfold difference. Here's another example here. All right, so pH. If you have any questions on pH, please let me know. The next section is buffers, and this is going to have to do with pH. All right, so if you have any questions, please reach out. Let me know.